In April 2015, a 7-car train broke the world speed record for anything that runs on rails to 603 kilometers per hour, faster than most airplanes at takeoff. 10 years later, that exact train still hasn't carried a single paying passenger. Not because the technology failed, because one governor, representing one river, blocked construction in a single Japanese prefecture for 9 straight years. This is the story of Japan's Maglev bullet train, a $69 billion machine that floats on magnets, cooled, colder than the surface of Pluto, built through mountains that are almost entirely tunneled and delayed not by physics,
This is far
but
worse
by
than we
water.
predicted.
Is far worse than we predicted. I'm afraid it is, Minister.
Japan already operates the Tokyo Shinkansen, the original bullet train line connecting Tokyo, Nagoya, and Osaka since 1964, the busiest high-speed rail corridor on Earth, now running close to full capacity. Rather than squeeze more trains onto that aging line, Japan Railways Central Corporation proposed something far more radical. A second route between the same 3 cities, built from scratch using a magnetic levitation technology the company had been quietly testing since the 1970s. In 2014, construction officially began on the Chuo Shinkansen, first a kilometer stretch from Tokyo's Shinagawa Station to Nagoya, with a later extension pushing the full line to 438 kilometers and reaching Osaka. Unlike most megaprojects in this series, this one isn't government funded. JR Central is a private company paying for nearly the entire line itself. The original target was audacious: open the Tokyo to Nagoya section by 2027, just 13 years after breaking ground. The most direct path between Tokyo and Nagoya runs straight through the Southern Japan Alps, a mountain range with peaks over 3,000 meters. Engineers had 2 options: wind the route around the mountains, sacrificing speed for a gentler path, or drive straight through them. Because Maglev trains need extremely gentle curves, a minimum radius of Basen meters, to maintain speeds near 500 kilometers per hour, Junior Central chose the second option. The final route is roughly 90% tunnel, making it one of the most tunnel-heavy railway lines ever designed, cutting through some of the most geologically complex terrain in Japan. Boring through the Southern Alps meant confronting rock formations far more unpredictable than surveys had suggested. In several sections, crews hit fractured, unstable rock that required extensive additional reinforcement before tunneling could safely continue. 3 of these tunnel sections ended up 5 years behind schedule, with completion now targeted around 2031 instead of the original date. A reminder that even Japan's famously precise engineering culture can't fully predict what's inside a mountain until it starts digging.
The rock density in Sector 4 looks inconsistent. Easy now, bring it up. Hold it right there, steady. Copy that, holding steady.
The line itself is a U-shaped concrete guideway lined with propulsion coils, built almost entirely underground or elevated to keep the route arrow straight. Unlike a conventional railway, there are no rails for wheels to grip. At cruising speed, the entire structure exists to guide a magnetic field, not a train chassis. The propulsion system is called Maglev, superconducting magnetic levitation. Each train car carries onboard superconducting magnets made of niobium titanium, cooled to -269 degrees Celsius, just a few degrees above absolute zero. At that temperature, the magnets carry electrical current with essentially zero resistance, generating an intensely powerful, self-sustaining magnetic field. That field interacts with coils embedded in the guideway walls, lifting the train roughly 10 centimeters into the air and propelling it forward with no physical contact at all. It's the same fundamental principle that let the test train hit 603 kilometers per hour in 2015, a record that still stands today. In commercial service, trains will run at a slightly more conservative 500 kilometers per hour. None of this was tested at full scale for the first time during construction. JR Central had been running Maglev trains on a dedicated test line in Yamanashi Prefecture since 1997, accumulating decades of operational data before committing to a full commercial route. Once open, the Tokyo to Nagoya trip will take just 40 minutes, down from roughly 100 minutes on the conventional Shinkansen today. But getting there has cost far more than planned. The original construction budget of about 5.5 trillion yen, roughly $34.5 billion, has been revised upward twice, in 2021 and again in 2025, pushing the total to approximately 11 trillion yen, around $69 billion.
Panel checks out, proceeding to main. Align the bracket before you secure it. We need this bolted down before testing.
Let's bring the speed up to 160.
Copy that, increasing to 160.
Every prefecture along the route eventually approved construction, except one. Shizuoka Prefecture sits directly above the headwaters of the Oi River, a waterway that supplies drinking water and irrigation to roughly 620,000 people downstream. JR Central's own environmental assessments suggested that boring an 8.9-kilometer tunnel segment beneath the Southern Alps National Park here could reduce the river's water flow, threatening both the water supply and a rare mountain ecosystem. For nearly a decade, Shizuoka's governor, Haita Kawakatsu, refused to authorize even preliminary test drilling in his prefecture. effectively holding the entire national project hostage over a single river. Every other segment of the line could be finished, and the train still wouldn't be able to run because this one stretch remained legally blocked. Kawakatsu resigned in 2024 after making an unrelated, widely criticized remark insulting farmers and factory workers, but he stated publicly that his resignation was really about his opposition to the Maglev project, not the comment that triggered it. His successor, Governor Yasutomo Suzuki, took a different approach: dialogue instead of blanket refusal. Suzuki convened an expert panel and demanded Junior Central formally address 28 specific environmental protection measures for the Oi River and surrounding ecosystem. By early 2026, the panel had cleared every one of those 28 items, and Suzuki announced he would finalize the Environmental Conservation Agreement with Junior Central on July 18, 2026. The final signature needed to release construction in the last holdout territory in the entire route. Even once that agreement is signed, the delay it caused doesn't disappear. The tunnel sections hit by unstable rock still point to a 2031 completion at the earliest, and Junior Central now targets commercial service as early as 2036, nearly a decade later than the original 2027 goal, at roughly double the original budget. It's a strange kind of lesson. A company that built a train capable of breaking the world speed record for rail travel, using magnets cooled nearly to absolute zero, couldn't out-engineer a disagreement over a single river's flow rate. When the Chuo Shinkansen finally opens, the ride from Tokyo to Nagoya will take 40 minutes. Getting permission to dig underneath one river took almost as long as it will take to build the entire 438-kilometer line. If you want to see what happens when the world's most advanced engineering runs into the oldest problem on Earth, who owns the water, subscribe now, because we'll be tracking this one all the way to opening day.
Your support from viewers all around the world is our lifeblood, the reason we keep working hard to bring you real value.